Hey guys, this is Notes 90. So the goal today is going to be able to solve any quadratic equation now using the different methods we talked about in the notes so far. So in this graphic here, think of it this way. When you're going to solve a quadratic equation, you have different choices. Now some of these methods will always work. So the quadratic formula will always work for any quadratic, but it's kind of messy and it takes some time. Graphing will always work, but again, it can be a little bit imprecise if the graph isn't neat. But you can use Desmos and do that whenever you like also. The ones that sometimes work are factoring and taking square roots. So these are faster to use, but they don't always work. And then guys, in this, because of the shutdown, we missed one method this year. It's called completing the square. This one you'll see in IM3. They'll kind of catch us back up when you come back next fall. So what's the clue to look for with the quadratic formula? Well, in this case, there isn't really a clue. This just always works. So if you're ever in doubt and you're not sure what to do, you could always use the formula. As far as graphing goes, what's the clue for graphing? I would say that if the equation is in vertex form, that's when it's most convenient to graph. But remember, you also have Desmos, so you can always just type the equation into Desmos and it'll graph it for you pretty quickly. The clue for using factoring, remember you want to find the discriminant, so b squared minus 4ac, and whenever that's equal to a perfect square, then you know you can factor at that point, and that's probably a little quicker than anything else. Lastly, what's the clue for taking square roots? In this case, this is where you're going to have no bx term. When there's no bx, for example, something like this, like you might say 4x squared plus 16 equals 0. When there's no bx term in the equation, this is a clue to be able to use this technique because you can isolate x by itself and then go from there. Again, these two methods don't always work, but when they do, they're a little bit faster probably than using the formula would be. So with that, the goal today is to try some examples. Example E. Solve 2x squared minus 11x minus 21 equals 0 by choosing whatever method you prefer. So in this case, I'm going to first find the discriminant. So I'm going to find b squared minus 4ac. Remember here, this is already set in form, so a is 2, b is negative 11, c is negative 21. So it's b squared, b is negative 11, so negative 11 squared, minus 4 times a is 2, and then c is negative 21. So at this point, this will just be a number, so I can just compute this out with the calculator. So I get negative 11 squared is going to be 121. And multiplying these three numbers together, 4 times 2 is 8, times 21 will be positive 168 in this case. If I add these up, I get 289. Now at this point, this is my discriminant. So what you can do is with the calculator, you can actually find the square root, and you want to see if this will be a perfect square, if this will come out as an integer. So if I do that, I get 17. So that means that in this example, the discriminant's a perfect square, so I know that this is going to be factorable. So let's just try factoring in this case and see how it works out. So remember, it's the x. I'll go a little faster here. So this is a times c, so it's going to be negative 42 because it's 2 times negative 21, and then b is negative 11. Next, we take our 42 and this is the factor pairs. Okay, you should be faster at this as you do it more and more. So it's 2 times 21, it's 3 times 14. In case at this point, I'm going to see that, I'm going to choose these, 3 and 14. Or make the 14 negative, and that's going to work. So now write the original question, 2x squared minus 11x minus 21. Remember that the whole point is to split the bx term into two terms, 3x minus 14x. So then I have 2x squared minus 21. And I'm going to GCF it three times. So first I'll group it. So here I take out an x, so 2x plus 3. Here I'll take out a negative 7, so I get 2x plus 3 again. Remember, in factoring I expect this to happen. And then I get 2x plus 3 as one factor, then x minus 7 as the other. Now to solve, remember we take each factor, so I'm going to take each factor, so 2x plus 3, and set that equal to 0. So 2x plus 3 equal to 0. And then I'll take x minus 7 and set that equal to 0. So if I solve these out here, again, this is a lot of work, but as you get better at this, you'll get pretty fast. You can kind of maybe skip some of these steps that I'm doing on the paper, if you will, and you can do it in your head. Some of this stuff you'll be able to do in your head. So then I get x equals negative 3 halves and 7. So again, this is solving by factoring. You could have chosen a different technique if you wanted to. It's whatever you prefer to use. Remember that you can always go into Desmos, type in the original question, and you can check to see where the x-intercepts are. Those are also your solutions. So at this point, pause the video. You're just going to do examples from here on out, and when you come back, you can kind of check your responses. Alright guys, so example F. So here I identified A, B, and C. I found my discriminant, and in this case I get a negative 103. Because this is not a perfect square, it's not factorable, so I can't use that method in this case. Also, when it's negative, I'm going to have complex solutions, so I expect to have an I in my answer. So I'm going to use the quadratic formula, because that always works. So here's the formula. Here I get a negative negative once I plug everything in, so I get a positive 3 out, plus or minus, that the negative in the square root comes out as an I, so there's my complex part of the solution. And then 2 times 8 on the bottom there is, 2 times 4 is 8. So in this case, this is a solution to this quadratic. Again, it doesn't look nice, but that's how that works. Our example G. In this case, notice how, if you look at it carefully, the way it's built, I can try to isolate this x here. So I'm going to choose in this example taking square roots. So here I'm going to choose a different method. This is probably the fastest method in terms of like getting an answer quickly. So I'm going to take square roots here. That was really ugly, so I erased that, sorry. So for this to work, I want to isolate this x by itself. So how would I undo this negative 3 times? I'm going to divide both sides by negative 3. Again, depending on how the equation is structured, you can choose different approaches. So then if I do that, I end up getting, this becomes a positive 9. At this point, because of the parentheses, this x is isolated, so now I'm going to get rid of the square. To undo a square, you take square roots to both sides. That the square root gets rid of the square. So here, x plus 4 comes down now free and clear. On the right hand side, it's going to equal a plus or minus, and luckily for us, the square root of 9 is nice, it equals to 3. To finish, I want to get x by itself, so I'm going to undo this plus 4 with a minus 4, and I'm going to feed that right here on the left. So I end up getting, I'll jump here on the side, x equals minus 4 plus or minus 3. And in this case, because there are just integers, I can split the plus or minus. Remember, we can do this. We can split this plus or minus into the 2 different scenarios. So minus 4 plus 3, comma, minus 4 minus 3. And find that x is going to equal to negative 1 and negative 7. So this is a bit quicker than using the formula or when we could factoring. Again, you can always graph this into Desmos, and you can check and double check that your x-intercepts are the exact same values as the ones you find when you solve. Alright guys, example H. So in this case, notice how looking at the structure of the original question, this is not even in standard form to start. So before I do anything, I got to move this negative 8 to the left with a plus 8 to make it standard form. Now that I have A, B, and C, I can find the discriminant. In this case, this is not a perfect square. So for me, I'm going to use the quadratic formula here, because I know it always works. Now when I use it, x equals negative b, so that's negative 14, plus or minus the square root of the discriminant, which we just found, all over 2 times a, which is 1. Now, 164 is a big number, but it is 4 times 41. And because 4 is a perfect square, I could simplify out a 2 So I can take a 2 out of this, leaving the radical 41 in the square root. Once I'm here, notice how all three terms share a 2 in common, so I can divide them all by 2. So negative 14 divided by 2 is negative 7. 2 divided by 2 is 1, and then again here is 1. So that's why in this case, the denominator disappears because it's just over 1. So my answer is x equals negative 7 plus or minus the square root of 41. Okay, example I. So in this case, based on the way that it's built, notice how there is no x term here, so I'm going to take square roots here. I'm going to use that technique. So I'm going to isolate x. So first I'm going to subtract 5 on both sides. So that cancels. So I get minus 2x squared equals 298. Then I'm going to divide by negative 2. Again, I'm just solving the equation for x. So I get x squared equals to negative 49. And then lastly, to undo a square, use a square root. So remember the square root and the square cancel. And then I get plus or minus. And in this case, when there's a negative and a square root, it's going to be a complex answer. All that means to us is we're going to have an I. So the square root of 49 is 7, but because it's negative 49, it's going to be 7i. In this case, I'm done. See, using certain techniques when beneficial makes the work a little bit faster, and you have to go through the whole process of doing these other longer techniques that always work, but you have to be able to recognize when you can use what. Alright, example J. So I thought just for practice, we'd solve one by graphing. So notice how in this case this function is in vertex form. So we have A, H, and K. So with A being negative 2, I already know it's going to be a frown that's a little bit skinny, right? It's concave down, has a max, all those things from our graphs. For the vertex, I know it's going to be H is negative 3 and K is positive 5. So all that falls really fast. So if I plot this first point, negative 3, positive 5, which is going to be here, then I can try to solve by graphing. So in this case, once I have that, I have my line of symmetry, so that's going to be here on my vertex. And then I can make a table here just real quick on the side. So x, g of x, and I've already got my vertex, which I have in blue, so I'll put it in blue again here, negative 3, 5. And again, knowing that a is negative 2, remember it serves as a slope, if you will, from the next point to the right. So the next point to the right is negative 2, and I'm going to subtract 2 from 5 to find this is going to be 3. So at negative 2, 3, I have another point. In fact, I can mirror it there. To finish doing this, I can find negative 1. So in this case, I can input negative 1 into my original equation. So I'm going to do here on the other side of space. So I'm going to write the original equation. So minus 2x plus 3 squared plus 5. And I'm going to input, I guess I'll put it in red, this negative 1 that I'm choosing to input here. So I'll work it out. 3 minus 1 is 2. 2 squared is 4 times negative 2 plus 5. That's a 4, sorry. And then I get negative 8 plus 5 is negative 3. So I get the point negative 1, negative 3, which is going to be negative 1, negative 3 is here. And I can again mirror that. So notice how in this case when I do graph this, this is kind of the issue sometimes with graphing, that because I'm graphing by hand, I know I have two solutions. I know they're in between negative 4 and negative 5, so it's negative 4 point something and it's negative 1 point something. But because I graphed it by hand, it's not quite precise. So what you can do here is go to Desmos, type this function into Desmos, and then you can remember click on the graph on Desmos and trace it to your intercepts and get the precise answer. But at the very least, we practice graphing one more time. It is an important skill to be able to do in these multiple representations of the graph or the function. So that's how that works. Alright, example K. So now, how about an application problem with quadratics? So in this case, Bryce Harper hits a home run. The function to the right here represents the height in feet of the baseball in the air after t seconds. Guys, when we have these kinds of questions, the a value is going to be gravity. The initial velocity that the ball is hit with is going to be the b value. So it's positive because the baseball goes up. And the initial height is going to be the c value, where the ball is hit from. So this is where our a, b, and c. And then I ask you, how long does it take for the baseball to reach its max height? Whenever you get this question about how long, this is going to be a time, how long it takes to reach max height. This is saying, basically it's code for saying find the vertex. This just means find the vertex, which we have a formula for that of negative b over 2a. So that's what this requires in this question. So negative b over 2 times a. And we have those values here in our function in the question. So negative b is negative 128 over 2 times a, which is negative 16. And now I just compute the numbers. So negative 128 divided by negative 32, and that's going to equal to 4 seconds. So it takes 4 seconds for this ball to get to its highest point. So imagine the baseball getting hit, and we're saying it takes 4 seconds for it to reach its max height. Now, part B says, what is the max height of the ball in there? So for this, it just requires me to finish finding the vertex. So remember that the vertex is a point, hk. Well, we just found h to be 4. So now to find the k value, which is the max height, I'm going to input this 4 back into my original function. Remember that t means time. This is 4 seconds. So I'm going to put 4 seconds into t. And I'm going to just solve that. It's a little bit messy, so I'm going to use the bottom of my screen here just for a second. So negative 16 t squared plus 128t plus 5. But we just found time to be 4 seconds. So I'm going to input the 4 into those. And I'll get a number. So 4 squared is 16 times negative 16 is minus 256 plus, now 128 times 4 is 512, then plus 5. From here, 512 minus 256 is going to be 256, and then plus 5 is going to be 261. So basically, this ball was hit 261 feet into the air. That's the max height. So the max height is 261. And that's how that works. Alright guys, with that being said, to wrap up today's notes, let's bring it home. So what I want you to do is pause the video. Please try this last example, but you have one function or one equation here. I want you to solve this one quadratic using all 3 techniques. So you can kind of compare how they all work between each other. Okay, so pause the video and then come back and check your responses. Alright, so when we factor this, the first thing we want to do is look for a GCF. And notice how these both have a 3 in common, so I'm going to take that 3 out of each of these, and I get x squared minus 9 equals 0. At that point, I can just focus in on the x squared minus 9. But if I look at it carefully, isn't it going to be a difference of squares? Isn't x squared just x times x? And isn't 9 just 3 times 3? So I can factor this even more quickly by just saying x plus 3, x minus 3. So I've already factored my quadratic. So now I'm down to this form. And now to solve, notice how I can take each factor. So x plus 3, I can set it equal to 0. And I can take the other factor, x minus 3, set that equal to 0. And I can solve. So to solve this quadratic by factoring, I get x equals negative 3. And if I solve this other little equation, x equals to positive 3. So those are my solutions for this quadratic. But let's solve it now using the other 2 techniques that I've asked you to use. First, taking square roots. So to do that, I want to isolate x squared by itself. So in this case, I'm going to just move things around. So 3x, remember in this case I can use it because there's no bx term. So I can get x squared, x by itself here. And I can divide by 3. So notice how here I can get to x squared equals to 9. And to take a square root, I can do that. The square root kills the square, so x equals to plus or minus 3. And I'm done. If you compare the answers, here x equals minus 3 and plus 3, here x equals plus 3 and minus 3, same answer. Notice how in this case I think this is a little bit faster, but again, you can choose whatever you want. Lastly, to finish here, so here I'm going to have a is 3 and b is 0, c is negative 27. In this case, I'm going to leave the GCF in just to see what happens with it, leave it in. So with the formula, remember, I'm going to first find the discriminant. So I'll do it down here on the bottom. So it's b squared minus 4ac. In this case, b is 0, because there is no b in the equation. A is 3, and c is negative 27. So if I compute the discriminant here, first, I end up getting 324. Now, this is a perfect square. This equals to 18. If I take the square root, it's equal to 18. But again, I knew I could do it because it is factorable. I did factor it over here, so I knew I could do that anyways. So let's finish this off by using the quadratic formula. X equals negative b plus or minus the square root of the discriminant all over 2 times a. So negative b is a negative 0 plus or minus the square root of 324 all over 2 times a, which equals basically 0 plus or minus, and we just said that the square root of 324 is 18, so that comes as an 18, all over 6, which equals to plus or minus 18 over 6, which equals to plus or minus 18 divided by 6 is 3. So when you compare all three methods, notice how no matter which one I used, I got the exact same answer. Because at this point, you've been solving quadratics for a few weeks, you now have different tools to do that, and you can now choose which approach you want to take to solve. But again, it's based on how the equation is built. To recap, guys, factoring and taking square roots, so the factoring and taking square roots don't always work, but they're a little bit quicker when they do. And then the quadratic formula is very powerful because this always works. So if nothing else, you can always use this and get a response. Alright guys, take care.